Hi everyone. In our previous tutorial on heat balance, we saw a typical example of a steam to air heat exchanger. Now we are going to do the same thing with hot water. And the difference between the calculation in hot water and when compared to steam is in the steam calculation we have considered the latent heat of steam. Now in hot water calculation we have to consider the sensible heat of steam, and the sensible heat is calculated using the CP, or the specific heat of hot water. Now you can go to the previous tutorials to see how we calculated the heat duty on the air side, and then you can also visit the tutorial where we have done the heat balance for the steam to air heat exchanger. And now in this example we are going to see how we are going to do the heat balance for hot water. Now you know the heat duty is 2,45,000 kcal per hour. Now using this heat duty and the inlet outlet, the parameters which we need on the hot water side is the inlet and the outlet temperature. So the hot water enters at 130 and leaves at 120 in the heat exchanger, and the heat duty is already calculated is 2,45,000. Now we need the, for the further calculation, we need the specific heat of water, which is 1 kilocalorie per kg, and the delta T of water, which is 20 degrees, calculated from the above input parameters, 130 degree minus 110 degree. Now the hot water consumption is calculated using heat duty, specific heat, and the delta T. Now the consumption is, we will come to the consumption value, it is 12,250 kg per hour. This is actually a circulating water, so consumption says it is not consumed, it's a closed circuit, and this is the flow rate required by the circulating pump for the hot water heat exchanger. The same can be represented as 12.25 meter cube per hour, considering density of 1000 kg per meter cube. At, we can write at density 1000 kg per meter cube. So here we are doing two things. One is calculation of flow rate, and another one is even the even the flow rate of the circulating water pump flow rate. And you can even arrive at the specification of circulating pump from this, and based on the piping pressure drop you can add the head also. Normally the head is around 40 mlc or 40 wc in the case spot drop column. This may change, but it's mostly based on the length of the piping, number of bends in the piping, and the pressure drop across the heat exchanger. So now here not only the heat balance, we can also do the check on the specification and rating of the pump. I hope this was a very useful session, and I request you to let me know what further calculations or tutorials are required by you. I will make use of your suggestions for the future videos. Thank you very much.